Good afternoon. This is homework help for your test 4, and this is number 4 on your practice test. Okay, so this is your practice test version A, number 4, and what you are being asked to do here, and actually let me just go right back here. Okay, so what you've got is you have this function: approximate the area of the region bounded by the graph of f of t equals cosine of t over 2 minus 3 pi over 4. And the t-axis, so you still can think about this as y and this is x. They've just labeled it t for this particular problem. The interval that we're looking at is pi over 2 to 3 pi over 2, and you are being told to use 4 subintervals, and then we're going to use the midpoint of each subinterval. Okay, so we've kind of got a lot of different things going on right here. So the first thing that we have to do that's a little bit difficult is we have to figure out each of our midpoints. So we are looking at pi over 2 to 3 pi over 2. Okay, and then we need a total of 4 intervals. Okay, so here is my first one, here's my second one, here is my third one, and here's my fourth one, but I have to use the midpoint. And so I need to find this point right here, this, so this is what I'm looking for. Now, the way that we do that is we say pi over 2 plus 3 pi over 4, and then we divide that by 2. That's how we find that midpoint right there. Well, pi over 2 plus 3 pi over 4, that's going to be the same thing as 2 pi over 4. So then what we get is we get 5 pi over 4 divided by 2. 5 pi over 4 divided by 2 is going to be 5 pi over 8. Okay, so this point right here, that's the midpoint of this first interval that I'm going to use, is 5 pi over 8. Okay, so now we know that we're going to be talking about eighths. So if I think about this pi over 2, I can think about that as the same way I would think about 4 pi over 8. This is 5 pi over 8. So that would be 6 pi over 8. So that means this subinterval right here is going to be 7 pi over 8. That's the midpoint of my second interval. Okay, so if this is 7 pi over 8, this is 8 pi over 8. So this midpoint of the next subinterval is going to be 9 pi over 8. Okay, here we would have 10 pi over 8, and then here we would have 11 pi over 8, and then here the end of our interval would be 12 pi over 8. So what we're doing is we are finding the value of f of 5 pi over 8, and then okay, so I've got 5 pi over 8. Then I have f of 7 pi over 8. Okay. F of 9 pi over 8. And then 11 pi over 8. Okay. Now, so our next step is we are going to take this value right here, 5 pi over 8, and we're going to plug it in for t. Okay, so that means cosine of 5 pi over 8 over 2 minus 3 pi over 4. Okay, so that is going to give us, so you got to be real careful right here. Okay, so you're plugging the 5 pi over 8 in for t. So we have 5 pi over 8 divided by 2, that's the same thing as multiplying by 1/2. So you got to be careful with that, okay? So 5 pi over 8 divided by 2 is the same thing as 5 pi over 8 times 1/2. Okay, so at that point, we end up with the cosine of 5 pi over 16 minus 3 pi over 4, and that's going to be 12 pi over 16. Okay, 4 goes into 16 4 times. 4 times 3 is 12. Okay, and so then we've got the cosine of negative 7 pi over 16. Okay, now when we find the cosine of that, you want to be sure your calculator is in radians. Okay, so grab your calculator, make sure you are in radians. Okay, and so I've got cosine of negative 7 pi. Okay. Sorry, guys. Okay, cosine of negative 7 pi over 16. And we get 0.19509. And I'm going to go ahead and take that to 5 decimal places. Okay, and that is the cosine. So what I have done is I have taken 5 pi over 8 and I have plugged it in for t. So just remember what's happening right here with that is going to give you 5 pi over 8 times 1/2. That's how I end up with my 5 pi over 16. I subtract 3 pi over 4, which is going to be 12 pi over 16. Okay, and then I end up with cosine of negative 7 pi over 16. Okay, and this is the cosine of that. Now, you're going to do the same thing with the rest of these midpoints. And so f of 7 pi over 8 is going to be 0.55557023. Okay, and we've got, I'm just putting a lot down just because, and you don't, I mean, 4 or 5 would be fine. I'm just going ahead and writing them all down. And then I've got f of 9 pi over 8. So if I plug that in, so I plug 9 pi over 8 in for t, and I end up with 0.8314691. And again, if you went to 4 or 5 decimal places, you would be fine. And then my last one is 0.980785828. Now what I'm going to do is I've got to add all of these up together. And students usually do okay with adding them all together. So I've got my first midpoint, my second midpoint, my third midpoint, and my fourth midpoint. So when I add all of these up together, I get 2.56291544. And students want this to be their final answer. Okay, this is not your final answer because what we have forgotten to do is we need to multiply by my change in x over my intervals. Okay, so I have 4 subintervals. And so what I have to do is I have to take the larger interval that I'm looking at. I've got to do 3 pi over 2 minus pi over 4. And actually, that's not my change in x. I'm sorry. the way I find my change in x is I subtract this right here. I subtract the area that I'm looking at, and then I divide by my number of subintervals. Okay? And so this is the distance that I'm looking at, and then I'm going to divide by 4. And I have to multiply. I've added all these up together, and then I've got to multiply by this right here. So 3 pi over 2 minus pi over 4, okay? I'm sorry, guys. This is not pi over 4. This is pi over 2. I knew there was a mistake right there. Okay. So I've got 3 pi over 2 minus pi over 2. So 3 pi over 2 minus pi over 2 is pi. And that's going to be pi over 4. So that is the distance in the width of each one of these subintervals. Okay, so this is my subinterval, this is my subinterval, and so it's that distance. So each one of these is pi over 4. Okay, so then I have to multiply this by pi over 4. And when I do that, my final answer to this is 2.0129. Okay. Okay. Now, the next one I'm going to do is from homework 5.7, I think. Yes, homework 5.7. And this is a great one. So this is homework 5.7, number 49. This is a very, very good one to look at. So 5.7, number 49. Okay, so I am finding the indefinite integral for x plus 2 times x plus 1 to the 1/4 power dx. Okay, we have to use u substitution here. So because this is the 4th root, that's what the 1/4 power means. So that means the 4th root of this. That is what I'm going to make my u. So I've got u equals x plus 1. Okay, and so then I've got du dx is going to equal 1. Okay. And what I'm going to do when I substitute this in, when I substitute these in, I'm not able to eliminate my x. So I'm left with x plus 2, and then I've got u to the 1/4 times du. Okay, so this would just be du equals dx right here. Okay, so now I can't do anything because I've still got an x right here. So I'm going to go back to right here, and I'm going to solve for x. So if u equals x plus 1, then u minus 1 is going to equal x. So I just took this value, and I subtracted 1 to get my x value. So now I'm going to go back up here, and instead of x, I'm going to put u minus 1. So then I've got u minus 1, and I'm plugging that in for this x right here. Okay, so u minus 1 is the same thing as x, and then I've got plus 2 times u to the 1/4 du. So now I can take the integral, and I can do the antiderivative here. I'm going to do a little bit more simplifying. So I've got u plus 1, I'm sorry, and then u to the 1/4 times du. Okay, now I can distribute that u to the 4th. So I am going to have u to the 5/4 plus u to the 1/4 du. And now I can take the antiderivative. Okay, so once I take the antiderivative, I drop my integral sign. So I have u to the 9/4 over 9/4 plus u to the 5/4 over 5/4. And that's going to be plus c because it's indefinite. I don't have any bounds. So I have 4 over 9 u to the 9/4 plus 4/5 u to the 5/4 plus c. Okay, and now my last step is to take this u equals x plus 1 and plug it back in. So I have 4/9 times x plus 1 to the 9/4 plus 4/5 to the x plus 1 5/4 plus c. And that is my final answer. Okay, so that is 5.7, number 49, and that is a good one to look at just because we have to solve for x and then plug that back in for the x, because when we do use substitution, we aren't able to get it all. We're not able to eliminate the x. Okay, now I am looking at homework from 5.8. Homework from 5.8, and this is number 29. Number 29. Okay, and this is the indefinite integral for tangent or inverse tangent of x over 1 plus x squared dx. Now, when you first start to work with this one, you probably want to make this your u. And that's a very rational, very common thing that students might want to do. But when I do that and I take the derivative of that, it doesn't help me cancel anything out. So that is not what I want to make u. What we want to make u is the tangent, the inverse tangent. So u is going to be tangent to the -1 of x, okay? Du dx is going to be 1 over 1 plus x squared, okay? So then we're going to have du equals 1 over 1 plus x squared dx. And so what I would do here is I would multiply by 1 plus x squared over 1, and that's how I'm going to end up with du times, and really we would probably see it written as 1 plus x squared du equals dx. Okay, so do my rewrite. I'm going to go ahead and do my u substitution. So I have u over 1 plus x squared, just to make that a little, so that u I've substituted for the inverse tangent, and then that's times 1 plus x squared du. Okay, these cancel, and I am left with the integration of u du. Okay, so once I do the antiderivative here, I end up with u squared over 2 plus c. And then my last step is to substitute my u value back, and that's inverse tangent. So I have tangent or inverse tangent of x squared over 2 plus c. Okay, let's see. Then we've got number 33. We're still on 5.8. So number 33. Okay. We have integration 9 to the x times sine of 9 to the x. Okay, dx. Okay, so our u substitution is going to be this right here. Okay, that's what we're going to plug in. So our u value is going to be 9 to the x power. We do a lot more with e to the x than we do with something other than e raised to a power. But we can still find the derivative of this. So du dx is going to be 9 to the x power times the natural log of 9. And this will be something that is on your formula sheet if you need it. So we just don't use it nearly as much as we use e to the x. So now I need to solve for dx. And when I do that, that's going to be du over 9x times the natural log of 9. Okay, and that equals dx. Okay, so a couple things that we have to remember here. I've got 9x times sine of u, and then I'm plugging in du over 9x times the natural log of 9. Okay, so then it's 9 to the x power. I did not write that correctly. It's 9 to the x power. I did that incorrectly when I was looking over these as well. So it's 9 to the x power. I'm going to cancel these two right here. And then I am left with the integration of sine of u du over the natural log of 9. Now, the natural log of 9 is a constant, okay? It's not the natural log of x, it's the natural log of 9. And if we plug that into our calculator, that right there is going to give us a constant. So I can take that out. So I can do 1 over the natural log of 9 times the integration of sine u du. Okay, so remembering how to find the derivative of 9 to the x power is something that we have to remind ourselves, and then realizing that this is a constant and I can just pull it out. That's something that we also have to remind ourselves. So now I'm going to take the antiderivative of sine of u, and the antiderivative of sine is negative cosine. Okay, and then we're going to have our plus c. So this is going to be negative cosine of 9 to the x over natural log of 9 plus c. Okay, and that is our final answer right here. Okay, and then I have number 41. 41, and this is still on 5.8. 41. Okay, so then I've got secant squared of theta times tangent to the 7th power of theta d theta. Okay, and just remember, that what that means right there, tangent to the 7th power of theta, that's the same thing as tangent of theta to the 7th power. That's just kind of reminding you that that's what that is. So what I am going to do for my u substitution, I'm going to make u tangent of theta, and it just takes practice. We have to just practice these over and over. Okay, so and then I've got du d theta. Okay, the derivative of tangent of theta is secant squared of theta. So now I'm going to solve for d theta. So it's going to be du over secant squared of theta equals d theta. Okay, and remember our u is tangent theta. So I'm going to go back here, and I've got secant squared of theta times u to the 7th power. So remember, u is tangent of theta, and tangent is raised to the 7th power. And then I'm going to plug in du over secant squared of theta. Okay, so those cancel. So then I've got the integral of u to the 7th du. Okay, so I'm going to do the antiderivative. I get u to the 8th over 8 plus c. Okay, and now I'm going to substitute tangent of theta back for u. So my final answer is going to be tangent of theta to the 8th power over 8 plus c. Okay. Okay. Oh, I think I might have one more. Yes, one more. Number 57. Number 57. Here we go. This is still at 5.8. So I am doing the integration, or the indefinite integration, because I have no bounds, of e to the x times cosine of e to the x dx. Okay, so I'm going to make u this e to the x right here. Okay, so u is going to be e to the x. Du dx is e to the x. So dx is going to be du dx. Okay? So now I've got e to the x, because I'm going to leave this e to the x right here. And we did some other problems where we left one of them. And so then I'm going to have cosine of u, and then I'm going to have times du over e to the x. And then these e to the x's cancel. And so I have integration of cosine of u du. Okay. The antiderivative of cosine is going to be sine. So I have sine of u plus c. And then my u value is e to the x. So I have sine of e to the x plus c. And that is my final answer right there.